The second sum, x is equal to a, b, c, d is a set given. Okay. And a relation is also given. You know that a relation is a subset of the Cartesian product. Now the question is, write down the minimum number of ordered pairs to be included to R to make it reflexive. That means this is not reflexive. You have to make this as reflexive. So R is given as AA. What are the elements of X? A, B, C, D, right? You have A, B, B, A, C. Do you have C, C in this? It's a definition of reflexive. For every A belongs to a set A should be there in R. So here if you take C, C is not there. So we have to add, what we should add now? The minimum they asked. CC, and also what about DD? Also is not there. So what we should add? We should add CC and DD to make it reflexive. The minimum number of ordered pairs to be included to make it reflexive. Next one is you have to make it as symmetric. So for symmetric, you just check the relation now. In the relation AA is there, BB is AC. If you take, if AC belongs to R, what should be there? What is symmetric? The reverse pair. What is the reverse ordered pair? CA should be there in R. It is not there, so that should be added. CA is what should be added? That's the question. So CA should be added. You need not write as a set, just write CA. Here also don't write the set. No need to write a set here. The minimum, okay. So CC, the element we are going to add it here. Already there is a set given. You are going to add an element. What is the element? CA should be added. Now come to the transitive. See, suppose if I take AA, starting with A should be there. If I take AA, just see what is starting with A, AC. Then what should be there? AC should be there. Do you have AC? Yes. If I take BB, anything starting with B? Nothing. So you need not check that. If it is not there, don't check. But if AA is there, AC is there, then AC is already there. Now you take AC. Anything starting with C? No. So it is already transitive. Nothing should be added. You need not add anything. Nothing should be added. Nothing. It is already transitive. Transitivity is you have to take two elements, two ordered pairs. If AB, then you start with B. BC belongs to R. Both should be there. Then AC should be there in R. If it is there only, you can check. Again and again I am telling you, if you can take these two from the R, then only we can check. That's what I told you. If I take BB, anything starting with B? Nothing, isn't it? BB only is there. If I take AC, do you have anything starting with a C? No. Only if you have something starting with a C, then only you should check whether the other point is there. It is not there. See, AA is there. Do you have anything ending is A here? AA means ending is A. Anything starting with A? Yes. What is that? AC, isn't it? Now you cut this, check whether AC is there. AC is there. So nothing to be added. Now the last one is to make it equivalence. Whatever you have written here, you should write again. To make it equivalence, you should add CC, you should add DD, then you should add CA. That's all.